Okay, so I'm going to plug in 2 here. So I want you to make a connection between the algebraic and the graph. So on the graph, we see this value of 2. What happens if we plug 2 into the function? So we get 2 minus 2 times 2 plus 3, which is 2 minus 2 is 0, and 0 times 5 is 0. So interesting, f of 2 is 0. In other words, we plugged 2 in and our output was 0. It's interesting. So let's plug in, what do you think would happen if we plugged in -3? So let's do that. F of -3 equals, this would be -3 minus 2 times -3 plus 3, which is -5 times 0, which is 0. Interesting. So that also, so this is called, that ordered pair is called a 0 of the graph. You've seen that when we trace, right? That's also a 0 of the graph. Because when you plug in those inputs, either of those x values, you output a 0. So you get 0 as the output for either one of those. And so that's going to be helpful for us. We're going to be able to test values very quickly to find out if that value we're testing is a 0. If we plug it in and we get 0, we get we found a factor there. So if we plug in a value, we found a 0 of the graph, we found a factor. And the other thing I want you to make connection between is this, and I hope you see this. Just get rid of this just for a second. So I hope that when you see that the solutions for this particular graph is the solutions are x equals -3. It's a negative, comes from that. And x equals 2 comes from, so those 2 points, really, -3 and +2. So those are the solutions. So the factors are x minus 2. The solution is x equals 2. Factor is x minus 2. Solution is x equals -3. Solutions factor is x plus 3. So it's the idea that the factor is always x minus whatever the solution is. Or in this case, whatever the potential solution is going to be. You'll see what I mean in a minute. Okay, so we're going to start learning how to do synthetic division. This is a shortcut for long division. So I know we've done a little bit of long division. This is going to be a shortcut for that. So you start by putting kind of a box, like a half a box. It's not really a full box there, kind of off to the left. And so in that box is where you're going to put your A value or your potential solution. So A, or think of it as your maybe your solution. But again, the form of this was x minus a. So a in this case is not -2, it's actually +2. Because again, we just talked about that. The formula there is x minus a is the factor here. So if you keep that in mind, you go, okay, the value we're testing, even though the factor is x minus 2, the value we're testing, we think 2 might be a solution on this problem. And we'll find out very quickly if it is or not. And so what we need to do is think about the coefficients of this next one. So the coefficients here are 1. -3 is the coefficient of x squared. I'm just going to kind of space these, +5 and -4. So I'm just going to space those across as we go. And so the weird thing we're going to do here is, so you kind of just always bring the first term down. You're adding here. So 1 plus nothing is 1. Now to get the next term, what you want to do is take this term times this term and put it up here. So this is what I mean. So we're going to take 2 times 1, and we're going to put that number right there. So that this 2 times 1 is 2. And we're going to add vertically. -3 plus 2 is -1. Same thing we did before. We're going to do 2 times -1, which is -2. I'll put that in the next column. 5 minus 2 is 3. 2 times 3 is 6. Put that next column. Add it together, you get +2. So what I usually do here is I draw a line to separate the remainder. So that's the remainder. And I'll show what these are in just a second. So I'm going to do the same problem a little different way. So I'm just try to do this quickly so we don't take too much time for this. So x cubed minus 3x squared plus 5x minus 4, x minus 2. I'm going to do long division and see what I get. So I get x squared. We'll do this fast. X cubed I'm trying to, so I'll probably make a mistake. Subtract that, which means I'm adding, which means negative x squared plus 5x. That's negative x or minus x, negative x squared plus 2x. But we're going to subtract those. So I get 3x minus 4, so plus 3. That would be 3x minus 6. You're subtracting, so you get 2 is the remainder. What's interesting, 2 is the remainder here. I don't know if you make this connection. Do you see 3, and the coefficient here is 1, negative 1, and 3. 1, negative 1, and 3. Oh, my goodness. So as I work backwards, this one's the constant. This is the x term. This is the x squared term. And you've got your answer there. So your quotient is, if you want to write your full answer like the way I like you to write it, your quotient is x squared minus x plus 3 plus your remainder, which is 2 divided by your divisor, which was, remember, we divided by x minus 2 here. So divided by x minus 2. Of course, the number we tested was positive 2 there. But that's your answer, doing the shortcut of long division, or synthetic division. If you do synthetic division and you try this, you'll get used to this. It's kind of fun. But you'll also want to make sure everything's very orderly. So let's start with our box. In the box, it's x minus a. So a is actually a negative 1 there. So be very careful about that. I'm just going to take my coefficients as they go. 5, 1, this next coefficient. I don't know if you see it. It seems like I'm missing a term here. There should be an x squared term, as there is not. So I'm going to put 0 here for my x squared term, and then 6, and then 2. So it's very important to not skip a degree. So the degree goes 4th degree, 3rd degree, 2nd degree, 1st degree, and 0 degree. So I've got all the numbers represented. First term just comes down at 5. Negative 1 times 5 is negative 5. Add, you get negative 4. Multiply, you get 4. Add, you get 4. Multiply, you get negative 4. Multiplying that number times this number to get that. 6 plus negative 2 is 2. Negative 1 times 2 is negative 2, and that is 0. So draw a line. That's your remainder. That's your constant. That's your x term. That's your x squared term. That's your x to the 3rd term. Go ahead and put some plus signs in there. And so now what's interesting, just like when we got a 0 remainder with long division, this is a factor, and this is a factor of that polynomial. So this is my quotient, it's also my answer, and it's a factor, which means x plus 1 is also a factor. Let's try another one. I think y'all are starting to get it. We should have some practice in a minute, but these go fast. Let's go ahead and try one. So 3 goes in the box, positive 3, not negative 3. So coefficients are 1, negative 3, negative 1, missing a coefficient there, so it's going to be 0 for x squared, positive 5 and negative 3. So first term comes down, this is 3, I like that, 0, 0, negative 1, negative 3, negative 9, negative 4, negative 12, negative 15. So I did that right. The remainder is negative 15, which means I'm going to work backwards going here. So that's the constant, that's the x term, that's the x squared term, that's the x to the 3rd term, that's the x to the 4th term. And so you have your answer. It's the quotient, which is that, plus the remainder divided by the divisor. And you'll have it. Okay, can I use the remainder theorem? So the remainder theorem is kind of an interesting little theorem. So we're going to use synthetic division, which we just kind of learned. in just a minute. But first, let's go about this the old-fashioned way. So let's just kind of solve this. So if I asked you what is f of -1, up you go. Oh, that's easy. Just gonna plug in -1 everywhere where there's an x. So this would be 2 times -1 squared minus 3 times -1 plus 1. So simplify order operations, do the parentheses first. So that's 2 times 1, or 2 there. Minus, actually, that's a positive 3, because negative times negative. So we get 5, 6. So f of -1 is 6. If we do synthetic division here, so let's try it. Synthetic division. So in the box goes the solution, which would be -1. There's a potential solution 2, -3, 1. Those have every degree there. You're good. This would be 2, -2, -5, 5, and 6. Interestingly, I don't know if you caught that, this is called the remainder theorem because our remainder was the answer to this question. So essentially, when you plug in a value into a function, the output of that is going to be the same as if you took that value, synthetically divided it, and looked at the remainder. And the thing is, well, you go, why wouldn't I just do this on the left? On the left here, I don't know if you see it, but there's, it's very easy to mistake on this work. There's a lot of order operations issues right in there that students will have trouble with, whereas this math is kind of easy. It's more mistake proof or safer to do this. And if you get the same answer of 6, by the way, you need to identify that your answer is 6. They'll ask a question like, use synthetic substitution to find the result when, and you'll see that in the homework. Look for the word synthetic substitution. They're looking for the answer is actually the remainder, or they might say using the remainder theorem. Let's try to solve this both ways. First, let's put this in the box and do synthetic division. So, by the way, -3, this is not the factor. This is just the solution. So I don't have to change the sign. It's just -3 there. Coefficients are 1, 3, that's a 1, 3, -2, and -6. Bring down the 1, multiply, I like that. -2, +6. Oh, I like that. Remainder. So you get, that's a constant, that's the x term, that's the x squared term. And so our answer here, though, is actually, the answer is 0. To use synthetic substitution to solve this one. So doing it the old plugging in way, I guess this is g, sorry, g of -3 equals -3 to the third plus 3 times -3 squared minus 2 times -3 minus 6. So this is -27. This is actually +9 times 3, which is +27. Oh, that's weird. +6 minus 6. That's weird. They seem to cancel each other out. I think I got 0. So g of -3 is 0, which is my answer, which is my answer over here as well. It's just the remainder. The remainder with these kind of problems, they talk about synthetic substitution. Remainder is the answer there. Let's try this one. So just step it up a notch. I think y'all are getting that. So if you work backwards, I can write a polynomial. So kind of working backwards, the factors, we've talked about this a couple times today. If the solution is +1, the factor is x minus 1. Solution is -2, the factor is x plus 2. Solution is +3, the factor is x minus the answer, x minus 3 in that case. Can I write a polynomial? So now I would have to multiply this out to get the polynomial. So let's FOIL that guy, get x squared minus x plus 2x is plus x minus 2 times x minus 3. Now I've got it's not really a FOIL, it's kind of a clam. You're going to multiply all the terms there. So x, start with this one. X squared times x is x to the third. X squared times -3 is -3x squared. X times x is plus x squared. X times -3 is minus 3x. -2 times x is minus 2x. -2 times -3 is plus 6. So I get x cubed, these go together, minus 2x squared, these go together, minus 5x plus 6. So that's just the idea of taking those and working backwards to solve. And one more case, can I find that from a function from the graph? And I think that's actually pretty easy here. So home graph x plus 1. This is just a little tip that might help you. I always like to put a time sign in between the parentheses. Sometimes Inspire has trouble recognizing that's implied multiplication. So I say times x minus 1. Oh, what did I do wrong? I think I put a time sign right there. Okay. Oh, wow. Got a lot happening here. So then you would go menu 5, 1. I think we've done something kind of like this. The maximum there is 0.219, comma 3.23. That's a max. This is not max value, it's just relative max or min. If you scroll left, there you go. I mean, when you're in trace mode here. So that's at -1, 0 is a min or a relative min of the graph. Try to use that. And if you scroll right, there is a minimum down there. Let's look at that. So that's 2.28, comma -9.91. And that is a min or a relative minimum. And I think that's it as far as finding the minimum or maximum points on a graph. Not too bad. And that's your lesson.